Good afternoon, all of you, for this second day of the Firstgreen webinar series on utility scale solar project development. I'm your faculty, Dr. Sanjay Basis from Firstgreen Consulting. I welcome you for the second day of the webinar. In previous days, we covered the topic related project identification. Today's topic is on project development, and we will have one more day to go, that is on project implementation. So friend, just to do a recap on what we discussed yesterday. So the agenda for the day is we will do a recap of the day one session. Then we will understand about the PV module selection, inverter and balance of system selection, contracting strategies, and financial modeling. Hope a lot of things will be going without PPTs. We will be directly jumping to some Excel-based tools, and I'm sure you would like it. I request you to keep posting your questions in the chat box so that we keep receiving those questions and we can address them right away. Don't ask the questions that we want a slide or you would like to have a video. They will be posted shortly on our website and you can download both video and PPTs and other related material from our website. We will be shortly publishing them on the website, and don't worry about the PPTs we are sharing with you. So just a recap, what we discussed yesterday was that if somebody is doing a solar project, he is in the conceptualization phase and he has to find out under which policy he wants to implement a project. He identifies which are the low-hanging fruits. Based on that, he will be finding out, which locations he can install, which are the states of his best choice, whether there will be good solar radiations, whether the site will be appropriate or not. And he has a couple of options to shortlist. He conducts the site visits to the locations, meets people, collects information about the project implementation process, the local regulations, physical assessment of the site, and all that. There are DESFR studies which are also done. And these studies, we discussed that there will be a yield assessment study, there will be a land survey, there should be a environmental and social impact assessment studies, there should be a technical assessment also. So all those things are done, and based on that, you reduce your number of locations to few locations, like you shortlisted, you did screening of multiple options to few options, and out of few options you have got a single location which is now finalized for project implementation. So in day two, we have reached to this level that we have to start the implementation of our solar project. So if we have to implement the solar project, now we are clear at what rate we are selling electricity. Our PPA terms are now clear to us. Who will be the off-taker? That is clear. Where do I install? That land has identified. We are also aware that to which substation we will be connecting our project. We are also aware, in which state we are doing, what are the policies and regulations, who will be your off-taker of electricity. So those things have already been done as a part of your field visits, and desk work studies as a part of project identification phase. Now we are moving to the phase 2, that is known as project development phase. So as we discussed, the project development phase is the actual phase just before implementation but finalizing the site. So the implementation phase will be coming tomorrow, but today this is the activity which we are at the stage when you have already finalized your site location, and you have decided that you will go. Your off-taker is also finalized, and now it is practically you are in the contracting phase. So this phase requires submission of permit application. You have to finalize your EPC contract. You have to finalize your module suppliers. You have to finalize your grid connection agreements. You have to also finalize your third party be conducting the yield assessment studies or environmental impact assessment or transmission route survey. Those things have already been done for your project, but this is the phase when you will enter in a much detailed analysis way. So you will also do the DPR preparation at this phase, and you will actually achieve a financial closure at the end of the phase 2. So we will be doing all the activities which are required to complete till financial closure. Once you attain financial closure of the project, then you move to your next phase, that is known as implementation of solar project. So I welcome once again to the day 2 of this webinar. I'm sure please keep posting your questions. We received yesterday a lot of questions, and we are sending those answers to all of you. So the key deliverables in this phase, that is the developmental phase, you will have your plant design brief report, that is basically your sort of DPR more on the technical side, as well as a DPR level work which you can submit to your lenders. You will have your civil engineering study, you have done your contour survey, you have given recommendation on foundations, you have done your geotechnical studies. In this phase, you will be doing all these type of detailed studies to be done at this site. So we have got the site. Now what all the activities are to be done in this phase, these are the deliverables. Another point you have to do is you have to do the transmission line route survey, right of way. You have to also do the grid connection assessment studies. So that is equally important to do. Because your site is now finalized, you can do on-site measurements of some solar radiation data immediately. You can also collect third-party data for your final yield assessment study. What we did in the preliminary phase is the first level yield assessment, but now you need a detailed yield assessment study, which is required to your lenders. Probably in this phase, you may go for paid data. You can also collect your solar radiation data from nearby operating plants also, and you can also collect data from state governments or the central government's solar radiation monitoring stations if they are available nearby to your site. So all that data will be available, and you will be able to do a detailed yield assessment study, because that defines the expected generation, and based on that your DPR will answer a couple of things, that how much will be the CUF, that is capacity utilization factor, and performance ratio. At the end of this phase, you will also have your plant brief design. You have also finalized your typical configuration of your project, what type of inverter, what type of modules will be required, how many modules in a single string. So all these things you will keep adding to your layout what way you will install the plant, where will be the road, where will be the drainage, how the land will be utilized in best way, where from the transmission line will pass from the land. You will once you have this, you will also have a BOQ, which will have a much accurate assessment of your your project cost. So you will have BOQ, and you will also have your DC and AC SLDs of the project. Before we go to those phases, it is important that some discussion is done on two critical components, that is module selection and inverter selection, because these are the two critical items on which the whole plant configuration will remain. So when you select a module, what are the considerations required? We will discuss in a brief about it. At the same time, we will also discuss, what all the considerations should be taken while selecting a inverter. Rest of the things will also are also important as a part of BOS, but we will discuss those items are in brief when we will discuss the DBR, that is design brief report. So module selection, basically at this stage you will be able to finalize your module supplier. You will be zeroing down what capacity or what technology in module you will be using, and how much rating of this module. You can also collect information. You can also visit module suppliers facilities to understand what all the protocols they adopt, what type of tests they are doing. You will collect a lot of information about modules, and based on that you will do that. We will have some analysis about that. Then we have the inverter also as a heart of your system, which receives the DC input from the PV modules, and you will be able to finalize your inverter. At this stage, you should be clear that whether you want to go with a string inverter or a central inverter. It is dependent on this decision is not only the yield specific decision, but it is also dependent what is your site conditions. As I discussed, like, is it easy to carry? It is also dependent on logistics, transport. It is also dependent on the site weather conditions, whether how is the temperature conditions at the site. At times it is also dependent what is your contour at the site. So these are the factors which affect the inverter, apart from the typical inverter efficiency. At this stage, you should also be clear that what is your BOQ. That means module inverter and your other items. If you have central inverter, then BOQ will be different. If you have got a string inverter, then the BOQ will be different. Whether you want to have a tracker or you want to have a non-tracker system, and your detailed SLD and BOS items shall be ready with you. Now, PV module selection, there are a couple of factors, but I would discuss some few important factors with you. The first factor which is important is to keep in your mind is the module mismatch losses. So while you are finalizing your PV module, you should ensure that the module mismatch is minimum. Even in your contracting, you can define the module sorting requirement. Modules are sorted in current sorted modules or voltage. Each module has a different current and different voltages. You can sort them. You can get these modules sorted out. So, for example, if your one pallet is having PV modules, about 50 modules, and each module is having their current rating ranging from 8.43 to 8.44 ampere, then your module mismatch losses are expected to be minimum. But if they are randomly packed in the pallets, then it is required to be sorted at site, because if you reduce your mismatch losses, then you can significantly save about 2 to 3% losses to module mismatch losses. You can do this analysis through TVSys by running the mismatch losses. In one of our projects, we reduce the mismatch losses even up to 0.5% by properly sorting out the PV modules. So maybe I will share some pictures with you how we can sort out tomorrow. Then you should also check what type of certification standard the module qualifies. Typically, the polycrystalline modules qualify for IEC 61215, and for thin film it is 61646 standard. Generally, most of the modules qualify for this, but you can check whether the module is meeting to those standards or not. Apart from that, then you should also check what are the typical frame conditions, how much is the frame thickness, whether the frame is with the anodized aluminum so that it can sustain rough weather conditions. So all these things you should check from your module supplier. The junction box is also equally important. You can mention all these things as a part of your purchase note, that your module technical specification or bill of material, there is a bill of material of the module also. So what type of EVA coating, what type of steel, the frame, how much is the glass thickness. You would like to have a ARC coating that is, so that anti-scratch coating is there on the glass, so that you don't have scratches on the glass. So all those things are part of the module BOP you should define. You should also define what type of junction box. It should be weather resistance, IP67, those type of standards are available for junction boxes. Then you should also check what type of warranty they are providing. Typically, the module suppliers provide 10 years product warranty and 25 years performance warranty with certain degradation conditions. And you should also check what kind of testing protocols or testing standard. Typically, the module manufacturers, once the module is done, they carry out almost 17 to 20 types of tests, which are like hailstorm test or PID test, or there's a list of those tests available. You can do Google and find out those tests. This is not the platform at which I would like to discuss those tests, but there are a number of, on our blog also we have published what type of tests are conducted on PV module. You can refer that. What type of module defects we generally observe? So these defects include, sometimes you'll find that the EVA sheet gets yellowish. It means the EVA sheet is degrading faster and it is not able to protect the backside of your module. Sometimes you will find that the glass, it is soiling and some corrosion, the glass is getting yellowish, or the color of the glass is getting degraded. And this is also one type of defect. It means the iron contained in the glass is more, and you should again go back to your module supplier that the module is not up to the standard. The glass breakage are the physical breakages. It happens due to installation. At times it happens due to installation malpractices. Sometimes your nuts and bolts are tightened or modules are strained. The glass breakage is a big problem when it is thin film modules. In case of crystalline, because you are tightening the aluminum frame, so you expect less of glass breakage, but it is an issue. Then bus bar corrosion is also one more factor which you should take into consideration. This is one more defect. So bus bar is getting corroded, and which is increasing to the losses. You at times find the cells are cracking. So there were micro cracks in the cells, and in due course of the time, these cracks have broadened, and you can see those cracks physically in your module. So this is yet another defect. the backsheet polymer also cracks. So sometimes the backsheet quality is not so good, and that also starts generating cracks. Sometimes the backsheet delamination also takes place. The backsheet leaves the sticking to the backside plate, and this also leads to protection to your module, and uh, the moisture can ingress inside the module. At times, you can also find out hot spots. Hot spots are manually visible, no, but not often. If you can find out those hot spots in the modules through thermal image cameras. So these are your typical defects you will find in the modules. I thought it is important to share this piece with you. At times, there has been a lot of knowledge gap between the module suppliers and the buyers. So what is that knowledge gap is previously people used to give step warranties like 90% degradation in the first 10 years and balance 10% degradation in the rest of the 15 years. So that used to be the language. It means even if in the 2 years your module has degraded by 10%, you are not liable to penalize the module supplier. So this issue was taken up, and now most of the suppliers are giving you a linear warranty. That means if your degradation rate is 0.7 or 0.8% per year, this should linearly degrade. It is not like in the first year you can have, but in the first 10 years, even if it is less than 10%, doesn't matter. So it matters. Every year it should come down. As a standard warranty, people give you that the modules will be degraded maximum 20% in 25 years, but actual degradation or estimated degradation is much lesser than that. The studies are done internally by the module manufacturers. Their estimates are that their modules will degrade by some 10, 12, maybe 15%. But when it is to give guaranteed performance, then they give a module degradation guarantee or warranty up to 20%. So that needs to be taken into consideration. One more important aspect which is nowadays coming up is the PID, that is potential induced degradation. So you will get your suppliers providing PID free module, or some module suppliers take a new thing which is PID resistant modules, and they have some requirement that if PID is observed, then the negative pole of the inverter needs to be grounded. So at times people ask me what is PID. PID is nothing but module is subjected to large voltages. If one string is having about 600 to 800 volt, and if such a high voltage is applied on two sides of the string, then it is natural that some electrons may bypass or may leak away. And because potential means when you apply voltages, at that time some leakage current happens to this high voltage, and this leads to faster degradation of modules. It is possible that in 2 years itself the module performance reduces by 50%. So be careful. PID is a big problem, and at times it is difficult. There is a fight between the user and the module manufacturer that it is onus on the user to justify that the module degradation is happening to PID. So there is a process to justify. You have to take few modules to the lab and take this to SGS or our NICE, where the testing happens, and we can get the PID. One more approach which we discussed while we are in the final developmental phase. Now we need to finalize which option of inverter is better. So there are approaches that is a string inverter, and there are approaches that is central inverter. So if you are using string inverter, then you will not use a combiner box. Directly strings will go to the transformer, to ACDD or whatever. If it is a central inverter, then all these strings cannot be terminated directly to the inverter. Then there is a new device which is known as string combiner box. That is that comes into picture. So this is the thing which you may require. Now let us discuss about the balance of system. So let me directly open it rather than waiting here. Yeah. So this is report which shows the design brief report. So once you have finalized, then you can prepare this type of report, which is I just wanted to share with you. Here you are defining the pitch and tilt conditions of it. Basically, it is a complete design, detailed design guideline for your project. At times, people do this and then finalize the EPC contractor. So, or if you have not done it, then the EPC contractor does it. My suggestion is better you do it and then call for the EPC proposals. That will be better. Yeah. So you can have the criteria for pitch and tilt design, that you are justifying that the losses should be less than 10%. You are also defining the soil conditions. You are also defining the cutting and filling guideline, that how much cutting and filling you will be doing. That is the civil scope. You are also mentioning the soil resistivity which you are considering for the plant design. You are also mentioning what will be your power source and at what voltage the power evacuation will take place, with which party the power evacuation is taking place, and what is the scope of EPC player, that he has to terminate to the injection point, or you can define that. The DC sizing, you can also define that how many strings, how many modules in the string you are considering. You can also define the bay extension scope in your module supplier things. Now, at times we have to define the PV module specifications. So if you look at this, you can see the module efficiency is defined, the fill factor is also defined. We have also defined that the module should be PID free. The tolerance is also defined, as we discussed. The frame, that is anodized aluminum alloy, which is also defined. You should also define that how much is the cable length in the PV module you are considering, because if you are considering connecting a first module to the third module, then it is better to go with a cable length up to 1.1 meter. You should also define the inverter specifications, that is what type of central or string inverter. how much efficiency you are considering, and at what voltage. So all these factors you should define. These DC cable specifications and makes can also be defined. For example, here these are the specifications and makes have been defined. The connectors, what type of connectors and their ratings and their standards, like it is mentioned that the connector should be IP67. The conduit, what type of conduits you will require. So you have specified that HDPE conduits will be required. Here you can also define your module mounting structure. So what type of structure you need and how much wind speed it can sustain. For example, the vertical post can sustain up to 150 kmph wind speed, and you have also defined the span between two this thing. You have also specified the thickness of vertical post, rafter, purlin, the standards of nuts and bolts, whether it should be GI or SS nuts and bolts, and these standard and the suppliers you have defined. The junction box parameters, then what type of transformer you need in your plant, that is also defined. The losses in the transformer should also be defined, that how much, like your full load losses in this case is 1.1% and no load losses are 0.15%. So these are the factors you are defining as a part of your BOQ specifications. You may require an auxiliary transformer for your auxiliary power supply, and for that also you need to define the things. AC cables and their voltage drops needs to be specified. So how much are the voltage drop conditions you are defining in your calculations. The HT switch gear is also important aspect in your BOQ of the plant. So you have to define what type of indoor or outdoor VCB breakers, what type of thing you are considering should be considered. HT cables are also part of BOQ. Then you have got AC SLD philosophy. So how the power will be taken up to substation. So here we are defining that it will be taken through overhead transmission line. There is the option of taking through underground transmission line. What type of ACDB you will require to power your auxiliary load. The plant also requires a UPS, that is to power your emergency loads. Auxiliary power supply, your peripheral lighting, internal lighting, they should also be defined. Weather station and the requirement within the weather station, how many pyrometers, temperature sensors, all those things you require. You should also define the SCADA and control monitoring things. And for this, you should check with your local agency. The DISCOM should give you the guidelines that what type of monitoring they require. Actually, nowadays, every plant which is a ground mounted plant more than 5 megawatt required to have communication with the load dispatch center, and for that purpose it is important that you consult with them and take their guidelines for defining the SCADA makes as well as the protocol of SCADA. The communication system is also part of SCADA. You should check that. The ABT meters and their specification needs to be also checked with the DISCOM. Cable ties, CCTV cameras, then module mounting structures, foundation work is part of civil work. Then plant fencing is equally important, that what type of fencing, your barbed wire or a peripheral wall you want to create. So you have to define that. Your transformer also requires separate fencing as per the grid protocol, and you need to do a separate fencing for your, even if it is within the plant. Then the road network and water drainage along the side of the road has to be defined. Then water catchment area also needs to be defined. How much is your water catchment area, and based on that, you can also define your 4-pole structure guideline, that how power will be evacuated from the 4-pole structure. Then your security cables, Your earthing guidelines should also become part of your BOQ, and that's it. So maybe you may not have that much knowledge to create this type of BOQ when you finalize your detailed design. But if you don't have this thing and you directly appoint a EPC, then if the price is freezed, then you cannot surely reach to this level of BOQ. So my suggestion is that you should create your own BOQ through internal team or hiring a consultant, and then get done the project costing with the help of your consultant, and then call the multiple EPC players to take the quotes. So then it will be a full comparison. Otherwise, without this, if you are simply saying that I want to install a 10 megawatt plant at this land, please give me your quote, then you are not competent enough to finalize what will be the condition for your how to compare, quotes received from the different EPC layers. So that is important. Just to share some guideline about the the module layout. So we should try that the layout should have a mirror image. It means if you look at this layout, you can see there is a mirror image of two sides, and from center there is a central corridor which is a road passing through, and because this project uses the central inverter, so in between there are inverters and they should not cast shadows, so some space has been left. The location of transmission line and four-pole structure should be at such a place from where final power evacuation is taking place. So if your substation is on right side place, then it should be here. If your substation is on left side, then it is better to keep this section here and take the thing. So all these things are taken into consideration, and you should create appropriately the blocks of PV modules so that your array fields are well structured. In between also you have to provide some walkways so that your cleaning equipment can move comfortably, and it should look a good design, so you can ask for a reviewer who has a good understanding of module layouts in your plant, how he want to make best use of your land. That is very important. So it is important that you spend a lot of time on finalizing this layout. Now we have reached to a stage when we have finalized our project. Now we need to appoint an EPC contractor primarily. So this is the phase in which we need to finalize a couple of contracts. So first thing is the finalizing not only the EPC contractor, but there are other contracts like the PPA also need to be signed. Module supplier, if you are buying modules directly, then module supply contract needs to be done. Maybe if you are buying inverter supply, then there should be a separate inverter supply contract. Land lease contract also to be done during this phase. You can also expect some guideline in this. Gone are those days. Nowadays not many people hire a single EPC contractor, so there are approaches to go with a single EPC contractor or multiple EPC contractor. The advantage of having a single EPC contractor is that a single party is responsible to do everything, and he is responsible to do guarantees and warranties of plant performance. But if multiple contractors are doing their work, then the electrical contractor will say that the problem is done by civil contractor, and civil contractor will say that no, the problem is done by the mechanical contractor. So you cannot force specifically, and the overall plant performance guarantee which is required by the banker becomes a challenge, because when you go with your project proposal to the banker, he will say where is the performance ratio guarantees and energy yield guarantees from the EPC contractor. Then if you have multiple contractors to do different works, then who should give you guarantee? That becomes a challenge. So anyway, there are ways to handle that, and maybe we'll discuss those things in due course of time. But I also wanted to discuss with you the inverter comparison also. We discussed the module comparison, but let us also discuss some example of inverter comparison. I hope yeah. So we are deliberately not discussing the name of the suppliers, but what you should focus is more on what are the parameters we need to compare with reference to different inverter suppliers. This is a comparison of inverter supplier from X company and Y company. So both inverters are 1500 volt. Then you have to check what is their startup voltage. You can also check how much is their MPPT range, so that should be as much as it is. Then how many are the independent MPPT inputs? Like in this case, there are 12, here it is 9. Then number of PV strings per inverter. So here it is 2, here it is giving 2 or 3. Then how much is the maximum input current? So here it is 26, both case 26. There's a requirement of this 26 ampere is that if you are using Y connector in your strings and you take 2 strings together in one input slot, then you require at least this much of input current. If it is 15 ampere, then you cannot take a Y connector connection to the individual input in your inverter. Then maximum current input, short circuit current, and MPPT booster output voltage. So this is also one important factor you should consider. AC power output, at what voltage you are getting the AC power output, that is also being defined. How much is the highest ambient temperature at which the inverter can withstand is one more factor. How much is the nominal AC voltage? What is the AC voltage range? In this case, 640 to 920. Then the protections are also important. So like PV string current monitoring, or DC side and AC side, both sides, if the inverter is giving switch, then it is good. You need not to put it separately. Inverter ground fault monitoring is, if it is available, it is good. Leakage current protection will also be helpful to you if you have got some information about, you want to know about the PID is happening or not in your PV modules. It should have, arc, smoke. So now we come to the next part, that is on the contracts. So the first contract is the land lease agreement. So land lease agreement, if you are buying the land, then there is no land lease agreement, you just bought the land. Otherwise, you do the land lease agreement from the people and you are taking the land on a long-term lease. So these are again multiple page contracts, but I'm just discussing few terms. So this contract talks typically about the term of contract, how much. So typically the term of contract is more than the life of your project, maybe 2-3 years or 5 years beyond the project life. So if you are doing project life is 25 years, you should do the land lease up to 30 years, because even after 25 years, it is possible that your plant may generate. So we have not seen that, but it is likely that nothing will end even after 25 years. It will remain functioning. So better to keep the agreement beyond that. Then the termination clauses, are also important aspect of. Then how you are paying the land lease. These are typical terms you can see of the land lease contract. Typically, 20 to 30 years you can expect, or you can construct the things on the land, and the property will be subjected to due diligence, and previously it should not have any right from somebody, and all those clauses come. Now, another important aspect is power purchase agreement. Power purchase agreement can be with your DISCOM, or it can be with your third party as a part of the open access power supply. So the first thing which is required is how much is the term of PPA. Typically, the PPA term is 15 to 25 years, depends on. In case of ground-mounted project, if it is the DISCOM which is buying electricity from you, then it is a long-term contract. Sometimes these contracts are short-term also. In case of REC projects, the contracts were short-term. So that's the reason the REC projects became less important to the people. Yeah, we are receiving a lot of queries that when we are going to re-announce the webinar. Sorry. This one is. Yeah. So sorry for a bit of small trouble, but we will continue. There's probably some screen related issues there.
Maximize.
The another issue which we were discussing was about the PPA related issues. So I will just discuss, a couple of issues. One is the LD clauses. So what if people do not pay to you as a part of your PPA? So if they do not pay you, then if it is a third party, then there is a take or pay clause, and as a part of termination, the off-taker has to buy those assets. That is the LD clause. If it is terminated, then the off-taker has to buy those assets. So that is the stringency in this. Another important factor which everybody is concerned about the PPA is what are the guarantees for my payments. So payment security, for example, all the SECI PPAs are having guarantees from SECI and subsequently from Government of India. It is the same case in NVVN and NTPC PPAs, but it is not the case in case of state government PPAs. For example, UP Discom, the guarantee is being given by the UP Discom only. So if the off-taker is having his balance sheet in red, then of course there will be challenges to get financing from the funding agencies, whether it is debt or you want to bring equity to the project. So PPA becomes a very important aspect for your project's financial closure. Be careful about it. In case of third-party PPA, it is the private party's balance sheet which matters. It should be triple A, triple B plus, at times up to B minus. Result rating is acceptable by the funding agencies. You can approach SBI and see their guidelines. Maybe in future we will do one more session how to get funding and what are the funding requirements from specific agencies such as SBI or ADB financing to Bank of Baroda. So coming to the PPA approaches, we were discussing that third party sale, then also the third party's balance sheet becomes important. There are take and pay clauses. If you are able to generate and if somebody is not able to consume, then also they have to. There is one more concern nowadays, which is you should be aware about the curtailment clause. The grid frequency goes higher and Discom is not able to offtake your electricity, and who will compensate the generator based on that. So those things are also defined nowadays in your PPA. Some of the PPA takes care that if there is a curtailment, then we will compensate you for the duration of the curtailment. So if that is there, then PPA is considered as good. But if that risk is not covered, then it is a problem. Now coming to the EPC contractor. EPC contractor is the most notorious level agreement you will be doing in your project. So for doing this, you need to define in detail the scope of work and the clauses. So the scope of work, of course, you have defined in detail the civil, electrical, and mechanical works. How much is the duration of the party? So typically the EPC will do commissioning of the plant and final handover, and his duration will be like he has to give a defect-free warranty 1 year or 2 year post handover. So some payment will be coming to him after 1 or 2 years. So his term goes up to 2 years in most of cases. The payment terms is typically milestone based. You can give some payment on advance. We discuss what are those typical payment terms, but some payments advance and balance are on milestone based, given on pro rata basis, depending on the progress. There are LD clauses that if there is a delay due to the EPC contractor, then what are the how it will be subjected to warranties. look at this, the EPC contractor payment with milestones. So once you have appointed the EPC contractor, the construction period is about 6 to 8 months. So once you have got a notice to proceed, at that time you will give advance payment. And then there's a PPPPP, then you are giving some milestone based interim payments on pro rata basis. And once you have achieved the final commissioning and he is transferring the assets hand over to you, at that time you are giving the final payments. So that is the typical payment things. But not only this, you are taking warranty from him. So this warranty goes even post handover, typically about 2 years. So then post there are some payments related to that, or he has to give you bank guarantee, and based on that you can release his final payment, and this bank guarantee should be valid as a part of his performance warranty for 2 years. The final payment which you are releasing should be linked with the delay payment. If he is subjected to some delays, then you have to put delay LD. If the plant is not able to generate adequate capacity, agreed capacity, then also you can have a LD, that is basis clause. If the plant is not giving you the PR output, then your EPC contract talks that there will be LD clause applicable. So any of these things will have a reduction in the EPC payment. So some of these clauses are being discussed. Sorry. So EPC contracts we discussed, and these are the detailed terms. We will share these slides, and you can refer the different clauses related to the EPC contract. Typically, the scope, as we say, that EPC is the engineering, procurement, and construction. So his scope of work as the engineering scope, that is the basic design, detailed design, and procurement. Then you can define the scope is inclusive of supplying equipment such as supply of PV modules, inverters, and all that. You can create a multiple EPC contract to a single party, which is like you are providing supply contract, service contract, and civil contract, because each contract will have a different tax conditions. So typically, the supply contract for module will affect 5% VAT. So accordingly, it is defined. So the price schedule which we were discussing, so we will define the price as rupees per megawatt or dollar per megawatt, and this is the typical payment conditions. You can give some payment about 10% at the time of notice receipt, and when you he releases the purchase orders to various suppliers, then you give 5% payments to them. Then completion of the site preparation and civil work, 5% payments is delivered, released. Once he gives you delivery of different components at site, at that time you can give 50-55% payment. And on the installation and commissioning, you give some 10% payment. The final testing and commissioning can have another 5%, and final plant handover or acceptance will have about 10% payment. So this is a typical breakup, but it is a negotiable breakup. But as an industry practice, we just shared these numbers with you. The final acceptance test, what all is required in final acceptance test. So that needs to be defined in the contract, and this is done on the basis of EC 62446, which defines the testing protocol for solar project, and based on that only you will do the testing and commissioning. So various tests are there at the local conditions, and accordingly you will do. And once the module has the plant has completed its testing, even PR, that is performance ratio test, is also done under these standards. You will give a provisional acceptance, and there might be some punch points left, which the EPC contractor will complete those punch points, and then we will give your final acceptance to the project. So there may be, you know, a little bit of here and there, some cables are to be corrected, some loose joints. You will give some 30 days time in which the punch point list needs to be corrected, and then there will be a final acceptance. So on final acceptance, you are releasing his final payment, accepting once he submitted the bank guarantee for the performance ratio or performance guarantees for 2 years, which is required. So the defect, that is known as defect liability period or defect or workmanship warranty. So anything goes wrong in module, but all viewers is the responsibility of the EPC player. The capacity guarantee that plant will generate that much megawatt is also part of this contract. Of course, the performance guarantee in the form of the PR test has to be done. At times, this is done by a third party on a clear sky day or for a week. That protocol also needs to be defined in the EPC contract. Of course, there are LDs. We discussed them, so I'm just skipping them. This is a very important aspect. Many times people ask me that what type of insurance policies are required to be taken by the EPC contractor. So typically, you know, contractors all risk policy he has to take, and the owner has to take, you know, a general liability insurance policy. Then you will be having the workers workman compensation policy is also be taken, so that if any damage happens to your workers, that can be covered. And the further issues related to you know, the guarantee or some loss of revenue insurance can also be taken from the insurance companies. Many times people even take the insurance for their expected yield. The insurance for corona, whether it is applicable or not, that needs to be checked from the insurance companies. There may be loss of generation due to COVID. Your people are not able to reach the site, the plant is underperforming, whether it is covered under insurance or not, that needs to be checked. Coming to the O&M contract, that is probably the last part of our discussion. The O&M requires preventive maintenance, corrective maintenance, and certain, you know, guarantees and warranties related to the plant's performance during operation and maintenance. So these are the things which you need to take care in the O&M contract. Typically, the contract you know, covers preventive maintenance, that what will be their cleaning cycle, how they will be doing the grass cutting. You are defining that what is the daily preventive maintenance plan, what is the weekly preventive maintenance plan, fortnightly, monthly, quarterly, and annual preventive maintenance plan. For example, daily, maybe weekly maintenance plan will ensure, you know, checking the loose connection in strings and all that. But transformer terminals can be checked on monthly basis, and some VCB or you know, things can be checked on quarterly basis. If the plant has got some problem or breakdowns are there, and then the corrective maintenance comes. So then there should be a response time. If it is the corrective maintenance which doesn't require any repair work, it is just online repairing required, then within 12 hours it should be corrected. But if there is repairing and some replacement is to be done, then response should come within 48 or 72 hours, depending on the contract. So I will just discuss some of the terms. So these are the contract parties and duration of the contract. Then we have got scope. The scope covers, as I told, daily, monthly, quarterly, and semi-annual and annual checks. Then reporting protocols. Then if it is corrective maintenance, then you should do that within 12 hours. If something is to be replaced, then it is within 72 hours. Then additional service contracts are also required for various other services, and you can also define your reporting plan. At times, the O&M contractor's scope also covers the O&M contractor scope, like security. So security is in the scope. So in that case, you have to define how many people you require really as a part of security person at the site. You have to also define what type of spare parts you need as part of your O&M contract. So the O&M service provider should keep some spares related to cables, connectors, modules, and all that. So a list of spare parts need to be defined in the contract itself. This is the typical contract for module supply. So you will release this as part of your purchase order. You will define the specification of the module, the price, delivery terms and condition, payment terms, what type of document you need, that is more important. So you need a full bill of landing for getting the custom clearance. You need original commercial invoice, you need packing list, you need insurance letter, you need flash test reports, you need certificate of origin. So these are the things please ensure apart from your normal things. Typical EPC scope sheet. It is good to discuss this as well with you. Yeah. Uh, just for the sake of what kind of things are required in EPC's scope, you can attach with their contract these type of things. Plant specifications, then scope of civil work, and these scopes are separately defined in various annexures. So you can define the supply of various materials we discussed: module, inverter, combiner box, breakers, ACDB, DCDB, and all those items. You can also specify the technical specification of each item you need from the EPC supplier. The civil related scope of work can also be defined to the EPC contractor, and you can also define the DC and AC side uh, drawings which you may require from the EPC supplier. Of course, you will agree with the schedule of implementation and accordingly this is done. We have exceeded our time, so I would suggest that we will take up financial model tomorrow. We can have adequate time tomorrow, so we will stop here and start afresh the financial modeling and then take up the project implementation. Thank you for your patience today, and we will surely cover rest of the items tomorrow. We will be happy to share the presentation slides as well as some material which is shareable from our side. Few things we will not be able to share, but the PPTs and some basic material we will be sharing with you. And of course, the video of this PPT will also be available for sharing. Thank you for your patience hearing, and we will just see what all questions coming from your side, and will attend them from the chat box.